Hello, this is Burton Samograd, and this is the start of a series of videos about a new application I've created, or am in the process of creating, called Skynet, creatively. So if you're interested in what Skynet is technically a Lisp machine. As Rainier or Joswig on Twitter pointed out, that's no Lisp machine. That's not like the Mac Ivory I have sitting under my desk. But then I explained a bit to him in 140 characters or less, or a couple messages, how it actually is a Lisp machine. It's at least got the idea of it. It just happens to be running in a browser, and running a machine inside another machine these days is totally cool and hip. So basically I'm designing this application, Skynet, as a hardware machine as a software machine. So if you don't know anything about Lisp machines, Google them. They have a really rich and interesting history. A brief overview is that they were some of the best development workstations available in the 80s that had features that were so out of this world that they were worth hundreds of thousands of dollars. They've kind of got a bit of a legacy. They're a bit hard to get these days. They're collector's items. And there's an interesting project to create a Lisp machine running on x86 hardware called Mazzano that unfortunately looks to have stagnated. So I'm getting a bit old. I've got about 20 years of programming experience. I've done everything from assembly to JavaScript. And I'm a bit too old to write in assembly or C anymore, which I still do sometimes. It's just not that fun. So I've taken to JavaScript and browser-based programming both at work and in my spare time, because it's just so frickin' easy. Sort of. That you can do like difficult things. JavaScript is no Lisp, but it's actually okay. I think it's pretty decent. Kind of feels like Scheme with curly braces and binding. One thing I miss from Lisp. Probably going to add that to my Lisp in this Lisp machine, but if anybody out there knows how to bind in Lisp, like bind arguments so you can curry them easily, it's probably in a book somewhere. It's probably on Lisp. I'll look it up myself. So where were we? So we're introducing what Skynet is. So Skynet technically is the thing on the left here. Oh, that's interesting. The first thing you might notice is that I can move the Lisp window listener around. So Skynet does have a full window system. There's no actual Z ordering yet. So that's something I'm probably going to develop later on. So the point of these videos is to actually show off both Skynet and its development at the same time. So if you're interested, tune into a later episode. I don't know if I'll do much development in this one. This is really just a first demo showing you the current status of Skynet as I've had time to write it over the past week. So, yeah. The cool thing is the window system to start with. It's not perfect, but it's basic. Now what we've got here is a listener, which in the Lisp machine world is technically your console. So this is a console which is actually built out of a component called a terminal. And the terminal is got editing capabilities and things like that. So what I'm going to do, this was actually my last session that you'll probably never see unless I release it on video. From a failed attempt to make one of these videos. And so I'm just going to refresh to get us into a clean state. So when you start up Skynet or just load it fresh, you end up in this state. Of course, the whole point is to make it fully configurable, but I haven't gotten there yet. But right now, this is what you get when you hit refresh. You get a bit of help, and quite literally, this is all that Skynet does right now. You've got a Lisp on this side that you can evaluate statements of, and you have a console with these commands. I think that's all of them. Oh, there's some secret ones that don't work yet, but I won't tell you about them yet. So, essentially, the console has a VI style movement keys. So, as you can see, I can move the cursor around VI style. It has insert mode, so you hit I. You can tell if you're in the insert mode by checking out the green border. Sorry, kind of thinking at the same time. So now that I'm in insert mode, I can type something. And one thing you might notice about this insert mode is it's actually overwrite mode. There's no actual insert yet. That's probably a feature I'm going to add in a later episode. So come back and tune in. It'll be probably not very clearly labeled, but you just got to watch all these because they're going to be awesome. You've got Z to clear the screen. Very important sometimes, because sometimes it's faster to clear the screen than to overwrite everything. So you just retype it. And what we're going to do, we're going to show off the cool feature, which is E. E evaluates the buffer in the Lisp. So we can do things like set variables. So that's your basic variable setting. Now we want to check the value of that variable, and it's exactly what we think it is. So let's set it to another value, and it's exactly what you think it is. So that's pretty cool. You know, there's no real exciting code. You can add. You can add, or you can add variables. And it's got your basic programming functionality in there. We'll go over what it has and doesn't have later, but there's not much. But that's where the fun comes in. There's nothing like working with small axiomatic systems to build something bigger. And that's partially what this is too. So it's partially the development of Skynet under the hood and the development of Skynet over the hood to create a as lispy of a Lisp machine as I can figure out. So, or maybe we can figure out in case people start watching and have ideas. So here we go. Now the next cool thing that you might notice is I'll refresh. So as you can see, we've got our last statement. We have our help again, and so if you remember from before the refresh, we defined X So one thing I always like to do is check what the current value of x is. And look at that, I refreshed and it's still here. That I think is part of what I'm doing from the Lisp Machine standpoint is to define cores, loading and saving of cores, which I think is one of Lisp's most magical features. So it's getting implemented first over language features and tested and being made sure it works very correctly. Because one of the ideas in Skynet future is the idea of loading and saving cores, and in fact, the main tenet of Skynet is that everything is code. Because as you can see, currently only the console will do anything with, except like it has to be Lisp code that you enter into the listener. So you can be editing your core. We'll go deeper into what cores mean and what they are later, but you can see on the right hand side here some of the debugging output that happens, and basically every time you evaluate a statement in the listener, the core is actually saved. So that is saved to local storage, and this is the size of the core, currently about 1K, and this is the contents of the core. So that might look a bit odd to you, or maybe not, but what it actually is Lisp code. It's every statement that's been executed by the Lisp up to the point of the save. So basically it makes loading cores really easily. You just refresh, load the core from local storage, and then you see it basically evaluates all the statements, and then you're back at the same state you were last time you left. So I think that's a pretty cool feature so far in such an embryonic system. Later on, some of these things, one of the next applications I wanted to write was a core editor, so you could actually go back in time, edit your core history, hit refresh. Things like that might sound a bit unbelievable, but I don't know, I think it would be kind of cool. So I'm going to implement it, because the main idea of Skynet future is the ability to share cores between other users, whether they're program cores or, well, they'll have to be program cores because everything is code. So you'll be executing code to basically do everything. One thing I do to remind myself of that is in my environment I have a variable. Everything is code in this world. So that's basically the central idea and complete list of features. Just kidding. There's a few other features, like the fact it has a Lisp, so we'll go over that. Oh hell, why not go over it now? Might as well. So, just to go over what we were just saying, here's some output here on the debugging side, and it's quite literally every statement that's been executed so far since I last reset my core being executed by the Lisp. So if you think that has performance problems, I don't think. We'll get to that later. There's actually a conceptual, well, there's an idea, not an idea, I've already done it, but there's going to be the idea of compiled cores. So there'll be a fast load, much like every other Lisp has. It'll be a FASL type file that loads really quickly into your environment. So that'll be a compiled core, so really it could be either sharing cores or sharing compiled cores, but whatever, we'll get to that in the future when we get to the actual server development part, which will be interesting. So that, oh yeah, we were actually going to be going over the Lisp. So quite literally, I think, other than, well, I'd have to look. This isn't quite complete, but there's basically not much more to the Lisp than this. So we have your basic set, q, cons, car, and cdr, lambda, apply, eval. So these are your McCarthy Lisp. You can actually select. So there's our McCarthy Lisp basic primitives, except for labels, which will probably be something that will be implemented in a later episode if you're interested in watching. So then we get into something that's a bit more advanced, which is multiple value bind and values, which, as far as I know, work, but I haven't tried them much. So the idea is you can return multiple values from functions and then bind them to variables locally. Now we have the all-powerful def macro. You know, we've got this bug. We don't want to watch me fix that one. That's just ugly. But back to the Lisp. So we have the all-powerful def macro, which, as we all know, is the reason why we use Lisp. We have probably a not very well working setf. I don't really, it might work with car and cdr, which I think all it really has to work with anyways. So yeah, so you might be able to setf car and setf cdr, but I have to test that later. And then you've got saving and loading of cores. So that's about it. So far in this core, I've defined a few functions, a few types. I've got a few defined functions. I've got pop, and I've got push, and then I've got a bunch of built-ins. Oh yeah, here's two things that aren't documented: RM and RMF. They are basically for removing things from the environment with a Unix name, because I'm a Unix guy and a Lisp guy, so we've got the best of all sorts of different worlds coming down here. So that's the Lisp so far. There isn't even let. You can do let with lambdas, but we've got to build up to let, which is some Lisp programming, which you might find interesting. Basically building a Lisp from first principles. And yeah, you might find that kind of cool if you're into that sort of thing. And I think that's about all I wanted to show right now. I can't think of anything else, except I really like that it reloads your last statement. Of course I really like it. I do everything I like in this thing. Yeah, I think that's it for now. So, thanks for watching, and tune in for another episode if you thought this was cool, because it's only going to get cooler.